Hello everyone, welcome to my final project for Electronics 2, the audio mixer amplifier. I wanted to do something fun with this. I thought, why can't I put my guitar and my laptop through one input and have the same output so I can play along with it to see how good my timing actually is instead of playing from across the room and trying to fight with it at the same time. And then at the same process, I wanted to put a low bandpass filter in. So I did that as a secondary, and then I discovered as I cranked that up, I basically had a car subwoofer. So it was a lot of fun, and I really enjoyed the project. The purpose of this project was to design our own audio mixer. I made two, a music/guitar audio mixer, and then a subwoofer amplifier. I simulated my designs, I built my designs, I have a small video of the testings, and I'll tell you what their actual comparison was like. And I had a lot of fun with it. So, this is the purposes of a guitar and a stereo. So the gain ended up being originally at a 1.5, figured out as the 0 on the 100K potentiometer and the 15 divided by the 10, and when I turned the potentiometer all the way up, I had a gain of 15. And what I found out on my simulation setup is I had a low decibel, 3.6, to a high of 23.5, so about a net gain of 20 decibels. What you're going to hear here at first would have been the guitar coming up first, and then the stereo coming in, and then the guitar dropping out, and then the stereo dropping out. Hard to hear on a sim, but you'll get a better one in the real one. Not perfect, but hopefully get the idea. So, this is the actual setup now. So what I did was my actual gain, my stereo got about an 18 decibel gain, my guitar got about a 16 decibel gain, and I actually measured this with a NIOSH meter through my iPhone. And the reason there's a variance is because, obviously with resistors you have real tolerances, 5%, 10%, etc. But I did measure my actual voltages in and out so I could get an actual calculation as well. So what you have here is the laptop, then the guitar, going through those first resistors, going through your RF, going to your op amps, and then straight out to your audio, and then of course your power from your breadboard for your supplies. So here we go. I don't have a distortion pedal hooked up in this video, so it's going to sound kind of clean and my playing is off, but just enjoy it. It's through my Gibson Les Paul. Alright, welcome to the first part of two of my audio mixer. The first one's an audio mixer, second one's an actual subwoofer guitar amplifier. So, here's what we got. I'm going to go ahead and show you the setup. The setup is very simple. Essentially, you're putting a resistor in series with your potentiometer to act as your RF, and then this is your base resistor, so as you turn this up, your gain will increase. The right side will be the guitar, the left side will be the laptop. So then it passes through the op amp, it is amplified by however the gain is changed, and then out into the stereo connection and out as one. So, essentially, what I'm going to do first is I will have some background music, and I will start it with both of them playing equally, and then I will turn the stereo music up, and then I will turn the guitar music up, and then I will turn the stereo down, and you'll hear just the guitar, and then I will turn the guitar off and fade it out. So, here we go. to fade out. Hopefully you enjoyed that. That was the actual guitar demonstration. So now I'll move into the simulated setup for the purpose of a low pass filter. I did this for fun just because people that like music like subwoofers. So the low pass filter, simply the frequency you want to cut out 1 divided by 2 pi capacitance times resistance. So that as you see here, I could figure out to cut out 63 to 482 hertz. So anything below that was let through, and that's most like rock and roll music and bass music. So hopefully in that you could at least hear the change. It's not the best, but you'll hear it in the actual video. As you see, I did the actual, just adding a capacitor in parallel with these resistors here, and then I add a potentiometer along the side. I actually figured out the resistor that I wanted by calculating the frequency I wanted to cut out. So here's the setup. As you can see, I just put the capacitors in and they came along the back side here. It's kind of hard to see. And then I put these potentiometers here. So as you see, 63 to 482 hertz, that's what I figured out that I got about. And the frequency comes in for the song of Tiesto, Wave Rider, if you've ever seen Hotel Transylvania for the battle. And you'll see that I cut the frequency out as it comes. So here we go. Last. Welcome to the second part of my testing, which is simply going to be a subwoofer amplifier. I wanted to experiment with this and just have a good time. I like music, so here we go. What I decided to do was something really simple. You take your basic circuit that you've already designed for your amplifier, and you just add a capacitor between the potentiometer output and also the output of the amplifier. And the only thing you're doing is putting that in parallel with the resistors to cancel out your high frequencies. I turn it up and also increase your gain. And then at the end of your output, you're increasing another 100K potentiometer, and this acts as your volume. So what I'm going to do is I'm going to start at the beginning with everything turned all the way down. Potentially no gain except for what's basically in the system. So the bass will be the same, and what I'm going to do is first crank the bass all the way up, and then I'm going to turn the volume all the way up. And then I will turn the bass all the way down. So you should be able to hear the tone changes very rapidly. Here we go. Alright, first things first, we are going to increase our bass. Hard to hear maybe, so we'll increase the volume. There we go, there's our volumes turned all the way up. And now we're going to take the bass away. Take the bass essentially out. That's what we got. So that's the end of my presentation. What I discovered, as you saw, the decibels weren't as high of a gain compared to the simulated experience, because the simulated experience is perfect, and then in real life your components, your resistances can vary. My actual volume capacitances were different, and then my actual 100K potentiometers on the laptop side only went from 0 to 90 kilo ohms, and then on the guitar went from 0 to 92 kilo ohms. So that's what I had for actuals. Those are my results. Hopefully you guys enjoyed the video.